So welcome you again to this lecture series of multivariate calculus. So in this lecture I will talk about the extremum value or this maximum minimum. Okay. So suppose we have some function. So here we have function of two variables. So in that first semester or the previous or your previous mathematics course, you know that for this variable, let's say if you have some function fx, only one variable, let's say some x squared minus 3x. For this function, you know how to find the maxima minimum, right? So what you do, basically you find out first what is the f dash x, right? F dash x, that is equal to 0, and from that you first find out what are the different x are there, and after that you again double derivative this term, and you see the what is the sign. If it is greater than 0, then you say that your function has minimum value at that point, and it is less than 0, then at that point it has maximum value, and if it is 0, then there is no conclusion, we have to do further derivative. Now here we have two variables, means this function is no longer a single independent variable. Now you have two independent variable x and y, and for this function we have to find out the extreme values, means either maximum minimum, right? So for the two variable, let's just find out what is the maximum minimum mean in the geometrically. Okay, how it does it signify? Because when you talked about function of xy, that's represent basically a surface. Okay, so suppose if we have this diagram where you have this surface, this bowl shaped surface or half sphere, and this point basically your maximum point, right? Because below this point all these value will be less than compared to this one, right? So this is basically your maximum point. Now another case, if you see this diagram, that's the opposite of this one, because that is basically half of the sphere, the other half of the sphere. So this is basically your minimum point, because if you any point if you take, then it will be below of this point. So value of this point of this surface will be minimum, other points the it will be maximum of the z value. So this is basically if you have the maximum value at this, in this minimum value, sorry, this point. Now if you can have this scenario also, what is that? Suppose if you have this complicated sort of graph where if you consider this point, if you go this direction, then it will be if you consider this curve, then this is basically represent your minimum point, right? But if you see this curve along this way, along this direction, then that is basically maximum point. So this point neither have minimum or nor maximum, this is called the saddle point. Okay, so previous for the first single variable you don't have this case, but for the double variable you have this case called the saddle point, where there is no maximum minimum value at that point, that is called the saddle point. Okay, so now how to find out? So for this single variable, you know how to find out the extreme value, what is the maximum minimum value. Now if you have the two variable, how to find out the maximum minimum value? So the condition for the extreme value or the maximum minimum value, let's say that the necessary condition. So here you have two condition, one is the necessary condition. Necessary condition also have two part. Suppose you have this function f of xy, and it has the minimum or maximum value at the point a b, then first one, that partial derivative of this function with respect to x at the point a b, it should be 0. Means first point is that whenever you have maximum minimum value of this function, then at that point your partial derivative of this function with respect to x, it will be 0. The same case for the single variable also. So at that time you have f dash x or f dash a equals to 0. So you have now 2 points a and b. So partial derivative of this function with respect to x, at that point it should be 0 for this maximum minimum point. Also the partial derivative of this function with respect to y also should be 0. So this is the necessary condition that this function will have maximum and minimum value at this point a and b. Now what is the other talking about the next condition, that is involving with partial derivative of order 2. So here it should satisfy this equation. See the equation. So we have the partial derivative 2 times of this function multiplied with partial derivative of f with 2 times with respect to y, negative of partial derivative of this function f xy mixed derivative, and that square should be positive. And this term basically denoted by r, and this only that function involving, so this term is basically denoted by s. So s is f of xy ab or f of xy, let's say simplification. Okay, and this term f of yy, partial derivative of this function 2 times, that is denoted by t. Okay, now we have to first see that whether this one is positive. So here we are finding out whether it is maximum value or not. Then it will be r into s, negative of r into t, x square should be positive, that is the one condition. Another one, that is if a partial derivative 2 times with respect to x, that should be negative. So this is also similar. So this case basically similar with that your single variable function. So at that time this function will have maximum value if 2 times derivative of this function at that point is negative. So similarly here it is negative, we are finding out maximum. So for this maximum it should be positive, and this partial derivative of with respect to 2 times x with respect to x, this should be negative. Now for this minimum case, what will be the condition? That function will have minimum at the point ab if it satisfy the following condition. It is the same condition of the previous. See, it is basically r, and this is t, and this is s square. Only difference here is that this is the greater than 0. The same case for the single variable data. So for single variable function, so at that time you have f double dash x is greater than 0. At that time you say that this function has minimum. So similarly here, if ab is greater than 0, and also this should be also for satisfy, this should be greater than 0, this whole term, then we can say this function has minimum at the point ab. Okay, and what about the saddle point, the last case, the point has saddle point, then this one will be less than 0. Okay, if this thing happen, that product of r and s square, so basically r t negative of s square, if it is less than 0, then at that point ab it has, the function has saddle point. Okay, no maximum minimum. Now let's walk to a example. Suppose we want to find out the maximum minimum value for this function x cube plus y cube negative of 3 of axy, where a is a constant, but I don't know what is the value, it might be positive or negative. So based on that we have to find out what will be the minimum maximum value or the saddle point of this function. So we have two variables x and y. So first we will partial derivative this term with respect to x. then it will be 3x square, right? Negative of 3ay. So we are partial derivative with respect to x, so it will be 0. So 3x square, and here negative of 3ay, right? And sorry, it will be y, and it will be 3y square negative of 3ax. Okay. The similarly, if we find out the partial derivative for higher order, then if I derivative this thing with respect to x, again I'll get 6x, right? This term will be vanish, it will be 0, and here if we differentiate with respect to x, then it will be negative of 3a, right? Because uh, with respect to x it will be 0, and here minus 3a will be there, and if of y, from this part we can get 6 of y. Okay. Now first we have to find what are the all the that stationary point. So stationary point means that where we can have maxima, minima, or saddle point, that is called the stationary point. So to find out the stationary point, I have to equate this fx equals to 0, and this one is also equals to 0, and I have to solve this these two equations. Then I have to solve this equation. So what I can do, I can take out the y value in the first equation, y, so that is equals to basically minus negative of x sorry, y equal to x square by a, right? And if I substitute this one in the second equation, then I will get x to the power 4 square, right? And negative of x cube, right? A will be cancel out, right? Sorry, no, ax. So here we are substituting y equal to x square by a, so it will be x to the power 4 by a square, then negative of a of x. Now I can take out x common here, then it will be x cube negative of a cube. So real root of this equation will be x equal to 0 and x equal to a. Now for x equal to 0, I will get y equal to 0, right? From the first equation, if I put x equal to 0, y equal to 0, and x equal to a, if I put here, then 1a will be cancelled out, y will be a. So we have these two uh, stationary point, 0, 0 and a. Now at that point, in this point, I have to see where we can have the maximum value, where we can have minimum value, where we can have neither maximum minimum value, that is called the saddle point. Okay. So we have to find out the higher order partial derivative, that we already find out. At that point we have to plug in this a and b value, then we'll get that is rt minus s square equal to this term we have seen, r and t we have seen that is 6x and that is 6y, so that is 36xy, and this one negative of some 3a, so 9x square, negative is already there. So here now we'll put x equal to 0, 0. If I put x equal to 0, 0, say it will be, this value will be negative, right? So I can say that at that point this function has a saddle point, neither maximum or minimum, right? No extreme value. Now what about a? If I put a that in this equation, then let's see, then we'll get rt minus s square is positive, right? S square is positive. So at that point we can have maximum and minimum. Now for this maximum, I have to satisfy this one, f of x a should be less than 0, then I can say that at that point we can have the maximum value. Now what happened if I put so r basically 6a, so I cannot put x and y value because it's constant. Now I don't know a, what is the value of a? A might be positive or negative. If it is positive, then R will be positive, right? And R is positive, and this then it says that at that point it has minimum value. Now if A is negative and the minimum value is this one, I have to put A in the given equation, then I will get the minimum value is negative A cube. Now if that sorry, if this is negative, then what happen? Then at that point, then R will be negative. So I will have the maximum value at the point AB, and the maximum value is negative of AQ, same value. Okay. So that's all. Thank you. See you in the next lecture.